Hello, welcome to another one of my video log recording sessions. It's been a while, about a week, I think, 6 days to be exact. Well, tonight is 2025, March 19th. And today I am going to cover the Jupyter Notebook file called Genetic Algorithm Grid Search 1 Rev, as in revised. So it is a revised version of the notebook with the same name, except that in this particular notebook I have applied the newer way of calculating the metric that I've talked about in one or two of my previous videos, which is calculating the average of top X% of the population, for example, in each at each generation, rather than averaging out the kinds of the different summed utility values. Rather than that, I am actually accounting for how many entities there are at each given summed utility value and averaging them out. So 6 days ago I filmed the other one, which is why I think I'm kind of rambling on. So let's just get started with this file. So in this file, I'm still covering 20 items. I'll get to 30 items and 40 items and 50 items later on, but for now it is just 20 items. So 20 items, the same as before. Values are the same, constraints are the same, and all the functions are the same except the compute average sum util function, which is the newly added function that I've shown in the very previous video. And in this case, this part has been modified so that I don't have to rewrite all of this. Instead, I'm using the favoring highs procreate function, where the weights at which entities are picked are calculated by dividing the population by 1, 3, 5, 7, 9, 11, etc. All the odd numbers. So that's that. So I'll try to make it quick, and then I set the hyperparameters as below. Population size is only 500 for now, and generation is set to 10, but this will change because the purpose of this notebook was to assess the impact that number of generations has on the evolution and effectiveness of entity generation with void genes. So that's that. So I create the void genes, I create the genesis and copy that to genesis 0, and deep copy. This is one of the things that have kind of changed. I don't know if I have mentioned it before, but I'm using the deep copy from copy so that whenever I make a mistake unintentionally, the elements don't get replicated throughout the entire population or gene pool or whatever. So and this is the code, not this. This is the code. Here what I did is create result dictionaries. Result dictionaries for the head, which is the top entity per generation. Result dictionary for the top 10%, for the top 20% and the tail, which is the entity with the lowest summed utility value. And I'm going to run this for 50 generations, and then 50 generations, stop there, reset, run it for 100 generations, stop there, reset, 150, stop, reset, 200, stop, reset, all the way to 3000 generations. So in total I'll be running it for 91,500 generations, which is why it took how long? Around 800 seconds on my MacBook. So on my Google Colab, it would take me around 3000 seconds. So I'm not going to do it here. I'm not going to run this. I'll have to wait, and the video would be 50 minutes long. Of course, I could edit it, but then it's not a video log. So here are the results. Well, this is one of the differences from the previous notebook with the same name. Here I have no, this is not the difference. I had that. I remember I had that. So if you look closely, the top blue squiggly line is for the heads. The orange one is for the top 10%, green one is for the top 20, and the red one is for the tails. So overall, even when applying and computing the new metric, or rather computing a new metric for assessment, does not really change the outcome. Rather, does not change the shape or the characteristics of the outcome, as we have seen something very similar to this when we were doing genetic algorithm grid search 1. Yeah, that one was the right one. So that's that. So now I'm going to run it for 30,000 generations with the same setting: head, tail, 10%, top 10%, top 20%. If you see here, I have these same redundant code, but I put that there in case I run only this cell, and then I forget to reset this, so I just put the reset here as well. It's a bit I'm sure it's bad practice, but it's a redundancy. It's not going to hurt. And this took 269 seconds, so about 4 times that, so it's going to take about 1100 seconds. Slightly more, slightly less, I don't know, but yeah, 1100 seconds. And here is the plot of that. Again, top is for the head, the top blue squiggly line. Sorry. Green one is for the top 10%, red one is for the top 20%. If you see here, the shapes, or the magnitude of the oscillations and the positions of the oscillations are generally the same, which is pretty much obvious. It should happen most of the times. And the head also oscillates, but and this is the tail again, the orange one. The purpose of this run was to see if an extremely large number for generations would increase, not the top, because again, for 20 items 710 is the max, so we can't go above that. We cannot go above red. And of course the average of top 10% cannot reach 710. It's just very unlikely. But I wanted to see if a longer time to evolve would somewhat generally raise the plateau level, or not. That's not right. would mitigate the plateau, or the score would go through some period of plateau and then slowly start going up again. But obviously, apparently that didn't happen. Now, whereas step number one, or phase number one, stage one, whatever, this was, the metrics were recorded at every 50 generations. Where is it? Where did I put that? I have no idea. One run. I have no idea where I put that. Am I actually going to have to do this again? I hope not. 50. Okay. No, not this. Oh yeah, I got rid of that. Sorry. My bad. My mistake. Previously, there used to be a step, which was step 3, where I recorded the metrics for per 50 generations, but now that's gone because I decided that if I was going to eventually evolve and record at every generation, that's going to be not, that's going to be redundant. I can also get the same plot by doing this, so that's why it was removed. So step 3 is evolve and record every generation. Generation is generations. The number of generations is set to 3000. Same setting. Reset it there. Again, redundant code on purpose. See, there's the code, but I don't use that. And then top 10% and head and tail. And what happens is it takes about 266 seconds. So again, around 1000 seconds if I run it on Colab, so I'm not going to do it. This is the distribution of all the entities. You can see that there's a huge number of entities with some utility values of 340-ish, but aside from that, it's kind of a normal distribution, and there are a few over here at 710 or something, but yeah. And then here are the plots of everything from the 10 times I ran, the heads, the tails, the top 10%, the top 20%. And this is, I know that this is hard to decipher, but I guess we can see that there is no increase again. And when we do this, when we zoom in for the heads until generation 50, they do reach 710. There's no plateau here when talking about heads, because this is the sole top entities that most often reach or go above 700. So 700 or 705 or 710. So they're going to stay here, and this is the most desired plateau level. But that again depends on the situation, as I have some time ago, long time ago, said that what is best now may not be best in the future if things change. So, but for now, this is okay. Not bad, not terribly bad. So they go up anyway. Good. Until generation 150, same behavior, same characteristics. And this is for the top 10%, but until generation 150. And As you can see, it goes up, it reaches that level, and then falls down a bit, and then plateaus outwards to the right. So this again, the dip isn't that big. However, it is still a dip, as you can see here. Which is which when I was doing this for the first time, doing this notebook for the first time, which I didn't mention. I don't think I mentioned it or talked about it in depth, but now that I have done so multiple times and we see it here again, I'm going to mention that there are dips here. But anyway, for the top 10%, this is how it goes. Very similar to what we have witnessed many times before. Same for again generation until generation 300. For the heads, this is for the heads, not top 10%. You see there. This is the top 10% until generation 300. There's the dip. Oh, if you look here, we did get that. So that's, amazing. I don't know if this will happen. It probably doesn't. And see, there's another green one. Nice. Because 300. Yeah. This phenomenon of recovering back to previous peak could be, for now, under this procreate function, could be because of the short length of the genomes, short length or relatively shorter lengths of the entities. That's it. That's it for now. For this notebook. Next up, I'm going to cover the genetic algorithm Grid Search 2 revised. But yeah, I might need to upload the notebook again since I don't want, or rather I want better plots here, more than 3 lines. Or not. Anyway, thanks for watching. Goodbye.